Hello everybody, and welcome back to another episode of Math with Mr. Emond. Today we're going to be looking at systems of equations, but specifically at solving those systems of equations algebraically. If you recall from last lesson, we were dealing with systems of equations that had different amounts of solutions. We looked at examples of systems of equations that had 0 solutions, 1 solution, 2 solutions, or some of them had an infinite amount of solutions if they overlapped perfectly. Now, hopefully you remember from Math 10, when you were working with linear systems of equations, that you can actually use algebraic methods to solve for them. You don't always have to graph them. And you would have learned how to do substitution and elimination in order to solve for those linear equations. Those same strategies that you would have learned in Math 10 are going to be applicable here, applicable to solving systems of linear-quadratic or quadratic-quadratic equations. So let's go ahead and give that a shot. And I know some of you might need a little refresher on how to do substitution and elimination, and we will do that. Don't worry. So let's take a look at example 1. In this example, we're going to be solving a system of linear-quadratic equations algebraically using substitution. And these are the two equations we're going to use. So the first one is y equals x plus 6. This is a linear equation. And how do I know that? It's in the form y equals mx plus b, where m is the slope and b is the y-intercept. We also have this equation here, y equals x squared. This is my quadratic equation. How do I know that? Well, this equation is in the form y equals ax squared plus bx plus c, where in this case our b value is 0, our c value is 0, and our a value is 1. So it's the most basic quadratic equation that you could possibly have. Remember that there is also quadratic equations in vertex form. That's the other form that we would have learned about. And that form is a x minus p squared plus q. So this is your vertex form. Okay, we have our linear equation and we have our quadratic equation. We're going to try to solve this now. So here's our steps. The first step is to isolate our y variable from, I'm going to change the wording from either to both. And in this case, they're already isolated. Our y value is isolated. Let's look at b. Substitute that variable into the other function. So in the case of linear quadratic equations, the order of operations for doing this is going to be, you're going to take what your linear equation is equal to. So here we have y equals x minus x plus 6. So I'm going to underline that. Y is equal to this, x plus 6. Now notice we have a y in our quadratic equation. What substitution means is we're going to take what y is equal to in the first one, and because there's a y here, we're going to substitute it. Because when we're looking at, here we have a linear and a quadratic. When we're looking at graphing them, and this is what we did last lesson, there's going to be 1, 2, or 0 points of intersection, right? Whatever points of intersection are, they're going to be points that have similar x and y coordinates. And so because they're going to have x and y coordinates that are equal to one another, we can use the substitution method to help to find them by saying that the two equations are linked algebraically. And so we're doing this by substituting x plus 6, which was what the first y value equation was equal to, and saying we have a y over here, let's put it in that equation. And when you do that, you end up with x plus 6, which is this part, equals x squared. And now what we want to do is we want to put it in true quadratic form, which is setting it equal to 0. So we're going to subtract x and subtract 6 over to this side. And so this is all gone now. And we're left with 0 equals x squared minus x minus 6. Now you should have an idea of what's going to happen next we are going to solve the quadratic equation by factoring. And if you cannot factor, then use the quadratic formula or complete the square. Let's go ahead and continue this. We can factor this. This is an easy one to factor. It's x minus 3, x plus 2. Which means I now know my x values for the points of intersection. Those x values on the points of intersections are x equals 3 and x equals negative 2. Unlike previously when you factor, this would tell you the x-intercepts. But because we're doing a substitution here, what this is solving for is not our x-intercepts. Instead, it's the x values of our points of interception. And so, with these points, we can now move on to the final step, substituting the resulting x values into the original linear equation to determine the corresponding values. So, for our first point, we'll call it P1. We know that the x value is 3. I'm going to get rid of the equal sign and do that. So I'm solving for the first point. And we have this formula here. Y equals, our x value, of course, is 3. So we're going to plug in 3 for our x value plus 6. And this gives us a y value of 9. Now we have our first solution. That solution, P1, had an x value of 3 and a y value of 9. Our P2, we're going to do the same thing. Y equals, this time it's an x value of negative 2 plus 6, which is 4. So P2 is x value of negative 2, y value of 4. So there are our solutions. These are our points of intersection. Now, in the previous lesson, we learned how to graph these. I'm going to kind of save a little bit of time here and use technology to graph. So our f of 1 is going to be x plus 6. This is our line. There it is. And now I'm going to input a second function here. And this one's going to be our quadratic, x squared. And we can see, I'm going to zoom out a little bit. We can see clearly 2 points of intersection here. Let's use our analyze graph feature to solve for our points of intersection. So I'm going to select before an intersection and after it. And I can see they've given me here negative 2 and 4, which is our P2, our second solution we found. I'm going to analyze the graph one more time, find another point of intersection. This one, I can visually see it, and it's 3 and 9, which was our first point. So we can see by solving algebraically, we were able to do the same thing and find the same solutions as solving graphically. Of course, if you don't have technology, graphing is much slower. So this becomes a very simple method for quickly finding your points of intersection. And it's very useful to have this knowledge. Let's go ahead and try something just a little bit more difficult. So now in example 2, we're solving a system of linear quadratic equations using substitution, same as before, but these equations you can see are missing a few steps and they're not quite as simple. So let's go ahead and work with this first one. We know that step 1, of course, is to isolate y. And let's do that. So to isolate y, I'm going to add y to both sides, and I'm going to subtract 10 from both sides. What this is going to do is eliminate those and eliminate these, and now the only thing on this side is my y. So I have y equals 5x minus 10. We're going to do the same thing on this side, but you're going to see it's going to require an additional step. So first, we're going to add 2y to both sides, which is the only thing I have to move because now I have the 2y over here. So that's going to give me x squared plus x equals 2y because these cancel out. And I'm not done because is my y isolated? No, my y is connected to a 2. So I need to get rid of this 2 by dividing everything by 2. And actually, I'm going to go ahead and do this separately so that people don't get confused. There we go. And the reason I did that is because 2 over 2 is 1, so that cancels out. So now I have for this y equals 1 over 2. Remember, there's invisible 1s here. 1 over 2 x squared, so 1/2 x squared plus 1/2 x. And there are my two equations that have now been isolated. Our next step, if we remember, is substituting one variable into the other equation. And when we're working with linear quadratics, we're almost always going to want to use our line. So here we have y equals 5x minus 10. So y is equal to this, and we're going to want to take this value, 5x minus 10, and we're going to substitute it in for the y in our other one. So let's go ahead and try that out. So you're going to have 5x minus 10, which is the y, is equal to 1/2 x squared plus 1/2 x. Now the next step, of course, is to solve the quadratic equation. And you can solve it by factoring, completing the square, or using the quadratic formula, whichever you think is easier. When I look at this, the first thing that I think of is, wow, that's messy. I need to clean it up a little bit. When I'm solving for quadratic equations, I want them to be equal to 0. And I want my a value, which is, remember, it's 0 equals ax squared plus bx plus c. This is what it should look like. I want my a value, so what's in front of the x squared, I want it to be positive. And that's going to help me factor. So if I look at my a value here, it is positive, which means I don't want to move this. I want it to stay where it is. Instead, I want to move these two things over to this side to get them away and for this side to be equal to 0. And the way I do that is I subtract 5x because 5x minus 5x is 0. But I have to do that over here, so minus 5x. And I need to add 10 because minus 10 plus 10 is 0. And over here I need to add 10. And now I can simplify. So here I'm going to have 0 is equal to 1/2 x squared. And then I have plus 1/2 minus 5, which is negative 4.5. Or negative 9 over 2, which is, they're the same thing. And if you don't believe me, you know, we can go over to this mode and do negative 9 over 2 and see it's negative 4.5. So just being good with converting between fractions and decimals, it comes in handy, like it just did here. X plus 10. And the reason why it was handy is because now that I see that these have the same denominator, and it would be really convenient if this value in front of the a was not just positive, but if it was equal to 1. Because when I'm factoring, remember, it's really nice when I can just put x here and they equal x squared. As soon as I have to change numbers in front of these, it increases the difficulty substantially. So how do I get this 1/2 x squared to be equal to just x squared? Well, I multiply it by 2, because 2 multiplied by 1/2 is equal to 1. And so if I multiply the entire left side or right side by 2, I have to do the same to the left side. So now we can simplify. What's 2 times 0? 0. What is 1/2 times 2? 1/2 times 2 is 1. So this is just x squared. What's negative 9 over 2 times 2? It's negative 18 over 2, but just so we are clear, negative 9 over 2 times 2 is negative 18 over 2, which is negative 9. So we're going to go negative 9 over 2 times 2 is negative 18 over 2. And then 10 times 2 is plus 20. we're going to simplify this. 18 over 2 is 9, right? So that's why the calculator spit that out. So x squared minus 9x plus 20 equals 0. And this, I can definitely factor it, right? I don't need to complete the square. I don't need to do the quadratic formula. Knowing how to work with these to get it into this form is extremely helpful because now I can just factor. 5 times 4 equals 20. 5 plus 4 equals 9. So I know the numbers are going to be 5 and 4. And it's x minus 5 and then x minus 4. So x squared minus 4x minus 5x gives me the minus 9x. And negative 5 times negative 4 gives me the positive 20. And now I have my solutions. X equals 5 and x equals 4. There we go. Last step. Substitute those into the original linear equation to determine the corresponding values. Okay, this is kind of the easy step, right? We're going to find our first point, P1, and that's going to happen when you substitute it in. So our line is y equals 5x. X in this case is 5, so I'm going to put 5 there, minus 10. That means y equals 25 minus 10, and y then is equal to 15. Okay, we have our first solution. Our first solution algebraically, our first point is x of 5, y of 15. Let's find our second one. So our P2 is going to happen when y equals 5 times, in this case, x equals 4 minus 10. This is y equals 20 minus 10 and y equals 10. And now we have our second solution, so P2. And P2 happens when x is 4 and y is 10. And there's our solution. And just to reiterate, we're going to graph this as well, just so you can see that solving algebraically does in fact work. Let's go ahead and do that. So we are going to graph it now. Our first one is 5x minus 10. This is our line. Our second one is 1/2, so 0.5, x squared, plus 1/2 x, so plus 0.5x. So there we go. And I can kind of see here that the points of intersection are, I'm going to get rid of these equations. Points of intersections are somewhere maybe here and there. And I'm going to need to kind of use my intersection feature because I can't really see it. So let's go ahead and highlight there. There, we found it. 4 and 10. That was our P2. Let's see if we can find the other point of intersection, which looks like it's somewhere there. Analyze graph intersection. Go before it and after it. There we go. There's the second point of intersection at 5 and 15. And that was our P1. So there we go. We verified graphically that our solutions do indeed work. Okay, it's going to be your turn. Go ahead and solve by substitution, just like we did in this equation. And when you think you have the solution or solutions, come back and check your answer. See you soon. Okay, welcome back. Let's go through the solution. So the first thing you should have done is isolate both equations. So you would have y equals x squared minus x minus 6 and y equals 2x minus 2. Then you're going to substitute your linear into your quadratic, and you're going to solve for it by factoring to find x equals 4 and x equals -1. Now you can find the corresponding y values. And so the corresponding y value when you plug in x equals 4 is y equals 6. And that gives you P1, 4 and 6. And the corresponding y value when you plug in x equals -1 is y equals -4. And that gives you P2. Okay, just so we have a little bit of closure before we end the lesson, let's go ahead and find your points of intersection. So there's one point here and one point up here. So our calculator is telling us at -1 and -4, which was P2, and 4 and 6, which was P1. And there we go, we verified our solutions graphically, which is always an option in my class because these calculators are allowed on departmentals. Might as well learn how to use them. All right, that's it for this lesson. See you next time. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.